Hello, everybody. Good morning if you're on the stateside. Good evening if you are in Europe, and maybe good night if you're in APAC or something like that. Hopefully, we've got a big international crew with us today. I'm very, very happy to be able to talk to CW Development about how they utilize our brand new white nylon 12. We're going to get started in a couple minutes. And just while we're waiting, we'd like you to respond to the poll that will pop up on your screen. The purpose of the poll is really just so we can understand a bit more about your needs. And, we will do this a couple times. There'll be a couple different polls, really about what you're doing with additive in general. And then at the end, there'll be more of a feedback poll as well. So, yeah. So first off, you're going to hear a couple questions about what you're using additive for. Please respond as openly and honestly as possible. This really helps us as a business, understand what the needs of our customers are or needs of our people that are interested in additive are. So I will stop speaking for now and let you engage with that poll. Great. So I'm already seeing we've got a couple people responding, and it looks like most people, so one of the questions is, do you currently use 3D printing for your business? And most people actually in the audience are already using 3D printers and already using a Formlabs printer. Looks like a lot of people are, it's like a mixed bag between people using 3D printing for prototyping and also for manufacturing aids. Great, so thank you so much for responding to that poll. We are going to get cracking with our content today. And here we're all about talking to CW Development today about how they are utilizing additive manufacturing, but specifically Nylon 12 white powder. This is a brand new powder for us, and I'm super happy to have guys here from CW Development. CW Development were one of our beta customers, so they have ultimately the most user experience that you could ever have with a product before it goes to market. They really helped us develop settings and things like this and gave us great feedback. Not only that, but they are also developing products for customers. And so we'll be able to go through that journey of why white and how to get the best results out of white from a real life user. Just to introduce myself quickly, my name is Adam Horrigan. I am a lead sales engineer here at Formlabs. And today I am joined by Gijs, who is the lead engineer for CW Development. So I will let Gijs introduce himself and explain a bit more about CW Development.
Hello guys, I'm Gijs de Munnik. I'm the engineer for CW Development. Thank you for joining this webinar. Let me start by introducing CW Development and telling you a bit about our journey. So we began 3D printing about 5 years ago, originally for ourselves, using the Ultimakers S5. When we heard about the Formlabs Fuse SLS, the first one, we directly signed up for the pre-order, and we were one of the first to use the machine. So at first we used the Fuse with PH12 for our own projects, but as soon as there became more materials available and our customers started asking us for help, we expanded our focus. So over time we grew from working only for ourselves to providing professional 3D printing services for a wide range of clients. So as of for today, we have standing like 7 Fuse a SLS printer from the 3L from Formlabs. So I can say we can handle more materials, more orders, and deliver high quality parts for our customers. So that's a little bit about our company.
Amazing. And I'm really happy to be able to speak to Gijs today. We've known each other for quite some time. So back in those days when you first got your first printer, I understand how much you've evolved because I've been there with you through the journey. And really what I love about you guys at CW Development is that you really are all about collaboration with customers. And that's kind of one of the reasons why you're so excited to get white, right? Like it wasn't just a case that you were happy to just use this new powder. You already had a customer that really needed this, right, guys?
Yeah, it was the number one question we got from clients. So the first question was, can you print it? And the second one was, can you print it other than the gray one?
Yeah.
So we're happy that we can offer this now to our clients.
Great. So we're going to come back to talk specifically about that client. Let's have a quick look at our agenda. So we are going to talk a bit more about the Formlabs ecosystems. As we know, there's some people in the audience that maybe don't know of Formlabs ecosystems too much. So we'll go through that for everybody so we're on the same page. We'll talk a bit about what specific materials CW is using with SLS right now. Then we'll talk about the different printability in those materials, naturally focusing on white and setting some expectations. And then we'll talk about how to use or why to use white nylon. Finally, then we'll have a quick look at how CW development, runs those ecosystems. What is the specific parts of those ecosystems for CW development that they use to get their desired results? And also, what are their services that they offer? Because there may be some people out there, hopefully, that want to use GUICE and CW development to help them, manufacture some parts even before you bring it in-house. That's one of the reasons we're so happy to have GUICE & Co here, is because they can essentially help with services for you as well. Then we're going to talk specifically about a product that they've been developing for quite some time now with NeoLook. Finally, then we'll look at the workflows, and then we'll leave it up for some questions and answers at the end. So we'll try to get through the main bulk of the content within 45 minutes. Let's see how we do. I will try to not speak too much. But let's start off by talking a bit about Formlabs. Just for anybody that doesn't know in the audience, we are really specialized in two types of technology right now. So we have SLA, that's where we come from. We started with the Form 1, and now we've gone all the way up to the Form 4 and the Form 4L, which you can see here. And we have a ton of SLA materials. Really, we pride ourselves on being a vertically integrated company. What does that mean for us? That also means creating technology and materials that enable that particular vertical to solve problems. So for instance, we have engineering resins, we have medical resins, we have dental resins. Naturally, in the resin world, we need to finish those parts because they are dripping in resin. We need to finish them safely and effectively and get great results. So we've automated our washing solution and our curing solution. And that's our SLA range. On the SLS side, we've literally just done the same thing. We've completed the ecosystem, providing end-to-end solutions for our customers. On the SLS side, we have the Fuse 1 Plus, we had the Fuse 1, and now we have the Fuse 1 Plus, which is all about enabling more materials and going even faster. We currently have 7 materials on our library, and we have a complete ecosystem, which I'll talk about on the next slide. So just to make sure we're all aware, there is different types of technology in the market. When it comes to plastics, we're talking about SLS, selective layer sintering, SLA, stereolithography, and FDM, fused deposition modeling. Now, we're going to focus on SLS and the benefits of SLS. That's why we're here today. Some of the main benefits for me, and probably for guys as well, being a designer, are that you can really print unlimited design complexity. What we would say is complexity comes for free. What does that mean? That means that we're not bound by a build plate or by being upside down like we are in the SLA world or the FDM world. AKA, we don't need to use supports, right? So that means that we can have really high detailed lattices or interlocking joints, and we just need to clean out those joints of the loose powder, and then we can have a fully articulated assembly without having to assemble 2 parts afterwards. Right, so again, think of a hinge, a living hinge. Those things make SLS really, really powerful. Something else, kind of in the same vein, is that because we have the ability to use all of the build chamber, and we can stack things on top of things, and that loose powder essentially supports our parts. All that loose powder can be recycled. That means that we can actually create a very cost-effective production. We can print thousands of parts in a build chamber, and all that loose powder, again, can be recycled into the next build, driving down cost and also meaning that we get a full batch of production. So we've seen a lot of people moving from prototyping into end-use part production, as we're going to hear from guys as well, using SLS for some of those benefits. The other benefit, naturally, is when we're using SLS, we are using thermoplastics that are biocompatible. For the most part, they are biocompatible with a couple of exceptions. And they are also UV stable, meaning we get really good parts that we can put out into the wild as such, with minimal post-processing needed. Just to illustrate a bit more about our ecosystem, so we have the Fuse One Plus, as I mentioned. That is the actual printer where the parts are going to be, fused together using, as we said before, selective layer sintering. Then when we finish that process, as I mentioned, we have fused parts and unfused parts, and we need a place where we can actually take those parts out of what we call the cake, and we can recycle all that material and mix all that material up so it's ready to go for the next build. That is all happening in the SIFT. The SIFT is a really powerful device because it enables us to mix very well and dose very correctly, because we need to use fresh powder and recycled powder. So how well you dose or your recipe and how well you get that recipe correct, that's all being handled by the SIFT. All the mixing, all the recovery is being done by the SIFT. It's also a very safe device because we have negative air pressure, which means that basically your powder does not come on top of you. You can even now get a glove box for this device, so you, again, don't have powder coming into your workspace. So this is what we had up until about 12 months ago, when we finally released our Blast. And the Blast is really for that final but very, very necessary step of cleaning and or polishing. That's why you can see here a compressor at the back of the Blast. We need to use compressed air. And then we're either going to use glass beads to clean off the final bits of powder. Otherwise, you're spending a long, long time in the SIFT, like an archaeologist, which is fun for about an hour, and then it gets quickly boring. I see guys laughing there because, again, imagine you're printing 1,000 small parts. Throwing those parts into the Blast and having an automatic tumbler means we can clean them very well, and then we can polish as well. Again, we're going to talk to guys specifically about these points about how cleaning and why polishing later on. Just to illustrate a bit more of the workflow of our ecosystem, as I said, it's complete end-to-end. So Formlabs provides Preform for free for all our customers. If you have not downloaded Preform, please do. If you're interested in using our ecosystems, that should be the first thing you look at, because it is essentially where you're going to spend most of your time. And I put my hand on my heart and say it's one of the best slicers I've ever used. I'm a bit biased. Maybe guys can tell us later on how you feel about it. But in general, that is where you're going to be spending your time preparing your files. As I said, in SLS, we can print thousands of little parts all on top of each other, or big parts, and we need to make what's called a packing or a packed job, combining those things together. If you had to do this all by hand, it could take you hours, but we've been working very tirelessly to make our algorithms work inside the technology, inside the software, so you don't have to spend hours in the software. You have algorithms that will get you to the place you need to be in terms of packing and preparing your jobs in the correct way. After that, we need to set up our printer. Essentially, we're going to take our powder from the SIFT and put it into our hopper on the Fuse. You never need to babysit the hopper, or never need to babysit the Fuse, essentially, right? It's not like pouring powder in as you're printing. It's not like one of those SLA devices that's maybe cheaper on the market, right? And we pride ourselves on the fact that you set it and forget it, essentially. You set up your printer, you prime the printer, which means you have everything inside, like a build chamber, and the powder. And then once you're ready, you send that job to print directly from your print or directly from your laptop, or you can send it via dashboard as well. Dashboard essentially is a tool that you can use to monitor your prints as well while they're printing. After that, as I illustrated before, our SIFT is going to be used for taking care of that loose powder on top of our parts, the bulk of the loose powder that we want to recycle, and also taking that loose powder and mixing it with fresh powder, which we call our refresh rate. After that, we are finally going to take our parts and put them into the Fuse Blast. And as you can see, the Fuse Blast has a tumbler here. You would see normally this thing's rotating around. Many blasters or traditional media blasters, you have to hold the part by hand whilst you use this glass media to get rid of the loose powder. That obviously is, again, quite brain numbing and not really a good use of most people's time. So we've been working very hard to bring the Blast to market, which is an automatic blaster. Not only is it used for cleaning, but it can also be used for polishing as well. So imagine when you want to have parts that need to be smoother and need to be a bit more, have a bit of a shinier surface finish, you would use plastic beads. So we have a polishing module that's an add-on for the Blast that will give you either a polishing for aesthetics, or it can also be for functional purposes, like we have with guys in the medical applications. So let's talk a bit about CW and the powders that you've chosen and kind of what the evolution was, guys, right? So as far as I remember, and I'm pretty sure, like most people, you started with Nylon 12, right? So talk us through what was your kind of decisions to get each powder?
Yeah, like as I said, we started 5 years ago. Then you had the choice between 3 or 4 powders, if I'm right.
Yeah, we originally started with Nylon 12 and Nylon 11. Yeah.
Yeah, exactly. So we choose to use PH12. It's mainly our most used material. It offers a great balance between strength, flexibility, and precision. It's highly durable, making it perfect for functional prototyping and end-use parts. Over the years, there became more materials available. So by the time we added Nylon 12 GF powder, that was mainly for projects that need to perform in demanding environments, because PH12 is more has extra stiffness and thermal resistance. So projects will need that. We turn to glass fiber, glass filled. After that, we added Nylon 11, just so we can offer our customers the option. Then the TPU 90 came. There's something really different. It's a material that's like rubber-like properties. We use the material for, as you can see on the picture, for handles. It is a actual part that we developed, and they are now using it on a bicycle that's completely recyclable. And
Can we talk about who the customer is, guys, on that one?
Yeah, sure.
Because that's a really cool example of using TPU for an end use part, right?
Yeah,
I just can't remember the name of the actual guys making the bicycles.
it's MTRL point bikes.
Yeah, and so the whole concept of that is that they're using recycled plastics, right? Like in their
Yeah.
bicycles, and they are like like more of a public bicycle, right? That you can rent out.
Yeah.
Super cool. Yeah, please continue, guys. So that we went to CPU. That was the second to last powder you introduced, right?
Yeah, and now we've added Nylon 12. Firstly, they asked to some beta testing for Formlabs S-Glass. So that's what we did, and for a month or so we are using it commercial. We offer it to our customers. It has quickly become one of our favorites because of the bright white color that provides a professional look, and it's ideal for parts that need to be painted or finished. Like I said, it was the most common question we got from customers, if we can print other colors, and now we can, and customers are happy about that.
Great. And we're going to talk through some of that way, or some of those ways and techniques of how to get different colors and what you were doing before to get different colors, and you know, how it's kind of improved the workflows a bit. So thank you so much, guys, for giving us the history. I think it's important for people to know, you know, like why particularly you as a service provider chose to go in that workflow. And again, really what we can see here is you have a lot of versatility, right? Everything from very high detail resolution parts to ductile parts with Nylon 11, then to more soft parts with TPU. Just so we are kind of having a broad look at what's on our offering right now, or our catalog of SLS powders. So as I mentioned before, we have 7 powders available, right? So we have Nylon 12, as guys mentioned, that's where we started. That's basically our first material. Then we introduced Nylon 11, right? And then we had Nylon 12 GF, Nylon 11 CF. So Nylon 12 GF, so specify, that stands for glass filled. Nylon 11 carbon fiber is the CF. Then we have TPU 90A. And then most recently, we've introduced 2 brand new powders. So this designers and engineers and people that are, you know, needing to print parts to understand what kind of parts and what expectation can I get from printing those kind of parts. So it's also going to give you an idea like what you may need to use in your setup in order to make that powder work. So as I mentioned before, in SLS, we're using a lot of heat, and how well that powder you know, survives that process of thousands of layers is what we call as printability, right? Something to bear in mind with white, so just focus on white nylon 12 over here. Because it is white, if we do not use nitrogen and we continue to use a low refresh rate, what we would see is that the powder would start to yellow. And it's not a very uniform yellow, so it won't be like, all slightly yellow. It'll be little bits of patches. And that's because what's happening is the powder is getting oxygenated. So to stop that from happening, we use a nitrogen environment, which is basically, this is one of the reasons why Fuse One Plus, we're so happy to have the Fuse One Plus, because that enables us to easily plug in nitrogen at the back, and it even gives you a monitor to show you, how much nitrogen you're getting and if you have enough nitrogen flow. So that's one important point. When we use nitrogen, we can use a low refresh rate. In this case, what I mean is 30%. That 30% is 30% fresh powder. So when we talk refresh rate, this is the amount of fresh powder you need to introduce to the mix. So in this case, when we use nitrogen, essentially we drive down cost of production. Without nitrogen, we'd have to use a lot more fresh powder to counteract the oxidization of the powder. Yeah. As you can see here as well on the printability, you will see some little bits and pieces. Most materials, there is some specific criteria about what machine they will work in. For instance, nylon 12 white will only work on the Fuse One Plus, as will nylon 12 tough, for instance. So that's something to bear in mind. Again, everything I'm showing you right now on the screen, it is a downloadable chart as a PDF. So anybody interested in this, existing customers think about switching, I would advise you to have a look. Some of the things that we maybe want to call out, I'm not going to go through every single thing here, but maybe just some things to call out. For instance, just so we're aware of what does it mean when we say fine feature resolution good? This basically means that what does it mean versus best, right? So as you can see here, we have nylon 12 white, fine feature resolution good, nylon 12, fine feature resolution best. So fine feature resolution, what we mean is, imagine just text or textures on a part. If we have textures or text that are below our design guidance, in things like nylon 12 white, there's a very strong chance it's going to be hard to see or it won't resolve, right? So when we use nylon 12 white, we will have to think about those parts and make sure that we are at least going with our design guide, which we'll also send to you, and it will be in the chat here as well, so you can see, or we're going above the minimum in the design guide. So that's something to bear in mind. So very, really fine features for nylon 12 white, for instance, text, you will have to enlarge those texts versus what maybe was resolving very easily on nylon 12. And this again is just down to how the powder resolves during the print process. Again, we're heating up a lot, we're moving a lot, we're changing. The build chamber is essentially dealing with a lot of thermal changes. Another interesting one, which I think is really good to talk about, the high aspect ratio parts here. So imagine parts here that are long parts. This is what we mean by high aspect ratio parts. And these can be really, really good in nylon 12 white, meaning that we are, again, we always have to bear in mind what is the part, the thicknesses, and all these things. As I said, the design guide is a great place to start. But these long parts would resolve much truer to CAD or much truer to design than, for instance, TPU, which is much softer material, and that's going to shrink and do different things inside the build chamber. Right. So again, we just wanted to call this out because this is a part of our, commitment to our customers, is making sure you understand the printability. If anything, like we would always say, let's test your design so we can give you the ultimate, the ultimate test that you can parts for yourselves for you. On mechanicals now. Oh, here we go. Great. So as I mentioned, as we can see on the slide, we have 4 nylon 12s right now. Nylon 12 is one of the most in demand materials on the market. As guys mentioned, is a really good balance of strength and also detail. However, within the nylon 12 market, we wanted to expand and to create, composites essentially with nylon 12 GF, which enables us to get to higher heat, like guys mentioned, right? So we're going to have an ability to survive in high heat applications or environments without our parts bending as quickly. Nylon 12 GF is also the stiffest out of the nylon 12s. So if we're thinking that we need to put a lot of load on something, we don't need that part to bend, nylon 12 GF would be the way to go. If we talk about nylon 12 tough, that would have a bit more ductility, as you can see here on this chart. Again, this is just pulled from our website. You can go and compare our materials on the website, either like this graphic chart here, or you can look at a bar chart, right? Nylon 12 Tough, as you can see, is less stiff, but much more ductile and much more impact strength. As we can see here, Nylon 12 White and Nylon 12 Standard Nylon 12, they are very, very similar in terms of mechanical properties. Both have really good, tensile strength and are very stiff as well. So they're great starting points for people that are looking for a good all-around material with a stiff plastic. Again, as I mentioned, that's one of the reasons why Nylon 12 is the industry standard, both in terms of balancing strength and details. So, what's super nice about guys having so many machines is we can talk a bit about the kind of ecosystems and how to work with those machines. Some people, when you have never used an SLS machine before, it can seem a bit daunting because it's powder. So now we're going to talk a bit about, guys, and how you manage those ecosystems and what particularly you have. So guys, let's talk about your SLS first off. Talk us through this
SLS,
room.
okay. So for like half a year ago, we moved to another facility, a new one. There are some things you need to keep in mind when you're starting with 3D printing. If you want to keep high quality parts and good material, you're gonna need some things in your room, like how do I say it? To ensure your machines perform at the best, we carefully designed our facility with the printing process in mind. So this includes air conditioning systems, to maintain a stable temperature. This is critical for consistent print quality. Dehumidifiers, so we control the humidity level, so we ensure that the materials stay dry. And also the ventilation and the air filtration is something to keep in mind for both the machine and the people who are working in the rooms. This is something for SLS printing to keep in mind. We now got a room with 7 Fuse ones, 2 with 5 with nitrogen, and 2 old ones. Also 4 Fuse shifts. And we have another room for the SLA printers, so we keep that apart from each other.
Just to mention, guys, on that one, like for people that don't know, the typical workflow is to use one Fuse material and have a specific sieve for that material, right, guys? We don't want to mix. Yeah. We don't want to mix powders, even if they are Nylon 12 and GF. They are very different settings, so we definitely cannot use those powders, and that's why guys has so many sieves as well, right? Because they're using multiple materials and they're using them around the clock. You can essentially clean out a machine and switch material, but it's not an easy process and takes time. Henceforth, when you guys need speed of the essence, right? It's the essence for your clients and for you. So you have one sieve per material. The only caveat, which I don't think you've used, is the Fuse depowdering kit. So if you want to test out a material essentially, and you're not really sure if you're going to run with that material, you want to just run a small batch, and you want to keep a sift full up with Nylon 12, you can just clean a machine and use the Fuse depowdering kit, which is essentially a manual post-processing or a manual sifting. Right, guys?
Yeah.
And so we spoke a bit about the sifts, and then you have 2 blasts, right? 2 Fuse blasts. Maybe talk us through why you've got 2 Fuse blasts.
Yeah, so one is dedicated to blasting the parts. All the parts that we print are blasted afterwards. And the other one we are using for polishing, so we don't need to switch between jobs and clean out the whole machine. That's something we don't think is in benefits for the product. So we keep those things apart.
Great. And one thing to mention about this, and it kind of is the same with cleaning a machine. Ideally, when you start with white, you should be starting with a new machine, because that is one of the materials. If you go from a gray material to a white material, it becomes very, very hard to clean, right, guys?
Yeah, it is.
And also with the blasting as well. Bear in mind, if you are using, especially if you're using a traditional media blaster, it can be really easy to contaminate a beautifully white part with some media and some powder from a gray part or a nylon 12 standard part, right? So that's something to bear in mind. And so we were talking about the blast, and now we have your SLA devices, right? So maybe you can talk us through those quickly.
Yeah, those ones are in a separate room. We don't want the powder to combine with our resins. We don't use it a lot. We mostly use it for prototyping for ourselves or some bigger parts. We do have a few clients we're printing for, and that's mostly specific materials like flame retardant or clear resins. But our mainly business is SLS printing.
Okay, great. And as we said, as you set up here, hopefully you're going to get a Form 4L soon, which should maybe see a difference in changes. Just so our audience know, the Form 4L really is going to set a difference when it comes to print quality, but also print speeds. And maybe just to quickly talk about this last little thing here for anyone that doesn't know, that's your tumbler, right? So maybe you could talk about that quickly.
Yeah, that's optional. We bought one because there's something you will see in this webinar also. We have a client that has parts that needs a smooth surface for spray coating. So we bought a tumbler, but I do say almost everything that we print will go into the tumbler and then in the polisher, just so we can give our customers high quality parts. It's optional. The parts that you don't have to, you don't need it, but we like to give it to our customers.
Nice. Talking about what you give to your customers, maybe let's talk about your services a bit. Why do people come to CW in the first place?
Yeah, CW is not only 3D printing. We have a few services that we can give to the customer. The first one is advising, choosing the right material, technology, or design can be overwhelming for some clients. That's why we take the time to understand your needs and goals, so we can provide expert advice on that. Then we have the modeling. If you have an idea but no 3D model, we can help you with that. So we offer 3D modeling, turning sketches into concepts. Also, modeling is important for the design optimization, because we see a lot that customers don't design their part for 3D printing, which I understand. But it's something to keep in mind when you're designing a product. And then, of course, the printing. Printing is the heart of what we do. So that's a little bit what we do.
Nice. And I think it's really nice that you have, as you mentioned in the beginning, that you're coming from a place of, traditional manufacturing and using 3D printing for many, many years, and combining those two things together. I've seen obviously many parts that you guys have made, and having that, holistic view means that you can give customers the best solution, right? Like everything from design right through to the actual printing, and being able to use those different materials really means that you can provide the right solution.
Yeah.
So maybe just to talk a bit about our Nylon 12 white and why we're so happy to have it. Here you can see a beautiful image of some of our hero products, or hero shots, as you can see here, from different types of applications and parts. So you can see everything here from a commercial controller to glasses to a drone cage to a dyed brace for someone who may be suffering from an injury. And so why we're so happy to have Nylon 12 white, what are the benefits and why you should think about choosing? Really, it's a material that's super easy to customize. As guys mentioned, most customers are looking to either create something that's in line with their existing brand, i.e. customize a particular type of part to fit with the end use part, or with, if you are in prototyping, essentially you want to give that to your customer and you don't want them to think of a different brand. You want it to be on the same colors and things like this. And so really Nylon 12 becomes very, very easy to customize to your aesthetic. We can do this in numerous ways. One way we'll talk about is dyeing, and we'll talk about dyeing a bit today. Naturally, it's white, and we provide really crisp details, and that helps us create contrast. Naturally, if you were to dye this black. You get really, really, really black very easily, for instance, with nylon 12 white. So it's not just about dyeing colors. You can also dye this material black and it'll be jet black. And it also creates contrast within your parts or your assemblies. It's biocompatible, which means that, for instance, the part that we're going to talk about with NeoLook, we can use this safely in an environment where we know that it's going to be easy to sterilize, easy to control microbial materials, and also that we're going to have the ability to create beautiful parts that are safe, essentially. It's versatile in the sense that we are a thermoplastic with really good accuracy. So that means that we can have interlocking parts, like I mentioned before. We can have, if we're going to see in the housing, we can have parts that fit together with and seamlessly, look as good as an end-use part or look ready to go just from taking some simple steps that Gijs is going to talk about later on. So again, just some benefits, guys. You've seen this already, right? Like you dyed, I'm pretty sure we consulted on it back in the day when you first started using nylon 12. Most people think, or get it, in your case, I don't think it was more of you think it was more of a customer saying, hey, can I dye this, black part or gray part to a different color? And how was it for you to dye nylon 12, for instance? What was what was it like?
At first, a bit messy. We tried it ourselves a little bit low level with pot dyeing. I need to be honest, after a few tries and errors, now we have it under control. So for the PH12 gray, we offer it also in black because we can easily dye the parts black. But other colors we don't recommend.
Yeah, because you can only really, sorry to interrupt you guys, but you can only really get like a kind of you can't really get a vivid blue, right? Like it's very hard to get
No, they are dark and not as bright as you want to be.
Yep. Yeah, and so when you've tried to dye, because you've also done some dyeing with nylon 12 white, right? So the amount of time it takes you to get it right is much less, right? With nylon 12
it was
white?
much less. Yeah, the first few tests were perfect. Yeah. The colors were very bright, easy to dye.
Yeah. Very nice. Talking about very, high contrast again and having the natural color that we have with this white powder, it makes it really suited for medical purposes as well. So imagine this use case on the top image here where we have a surgical cutting guide. This is a actual part that we know many customers or many hospitals, surgeons are super interested in using, because naturally if you are going in to do a very difficult surgery, to have a guide basically means that you reduce time in the surgery and means that you can be much more precise, right? And that's exactly what this is a cutting guide. And so we are already seeing many hospitals and other people involved in the medical industry super excited to use this powder. Again, imagine you're inside the skin of a patient, seeing a white part versus a dark colored part naturally is going to be much easier to work with. We also have less light absorption for this material. So think about if you are using light as a sterilizing method, this material is going to bounce the light as opposed to absorb the light. So be much more reflective, which can be really good for sterile environments. And we have great functionality as well. As you've seen from the technical data I produced before, it's very similar to what we have for nylon 12, which balances a lot of strength, but also really high detailed parts. So now we're going to talk a bit about the actual product that CW Development have developed over the span of quite some years. I'll let guys talk a bit more about the actual product life cycle and how they've now brought it to developing end-use parts in white nylon 12. But before that, just to talk about the actual company itself, we're talking about a company called NeoLook. NeoLook is specializing in end-use medical devices. As you can see here, this is an AI biosensing device that is essentially used for neonatal family care. With collaborating with CW Development, NeoLook were able to produce this actual part, which lives inside hospitals' incubators. So imagine children that are born prematurely, they can be monitored with these devices very safely, and those devices are spitting out a whole bunch of information that doctors and families can use to either respond or actually take corrective action they need as healthcare professionals. So this is the actual 3D printed part you can see here. This is not a render. And as you can see here on the left-hand side, this is what I mentioned. It's multiple components, guys, right? That you printed together and you spent some time to develop that. So maybe we can talk about, this is the beautiful end use part, but maybe let's step back a bit and talk about how you developed this and what that cycle was like.
Yeah, NeoLook came to us with a question. They had the design almost ready. But the design was organic and it had specific functional things on it. So the challenge was to determine whether 3D printing would be the right manufacturing method. Because like making molds, it's very expensive, and the small production series and the need for potential design change in the future made 3D printing the perfect solution. So after like 2 years, we now finalized the product. We've only, before we printed it in PH12, and afterwards they were spray painted. But now we can print it directly into white. So we, how do we say it?
You've really sped up.
Cheaper.
Yeah, you've sped up your workflows, right?
Yeah.
Because I noticed from us chatting offline, and you were not doing that painting in house, right? So you had to send it out.
Yeah.
Guys painting it were not necessarily the most fond of these kind of parts, because as far as I remember, they're not used to using this, and so you have to try and adapt. They have to try and adapt their workflows, and it becomes a lot longer. And obviously, the longer we wait, the more people we rely on, the more cost goes up.
Yeah.
And so with white nylon, you're able to paint this, or even not have to paint it at all, right? In this case, because as far as I'm, you will have to paint just one part of this, right?
Yeah, the bottom part.
The bottom part, as we can see here, right? But the top part, which is the bulk of the part, we don't need to paint that at all. So maybe we can just talk quickly about Nylon 12 and in general, your workflow. We're going to talk through this together, but just so the audience is aware, if you imagine Nylon 12, the first time you set up a machine with Nylon 12, we have to prepare the machine and prepare the powder. What do I mean by that? Well, the powder itself, when we print it raw or completely fresh, what happens is the powder has a tendency to clump together. That's why we run this powder aging cycle. So that'll be the same for Nylon 12 white and also Nylon 12 tough. We age the powder, which essentially just means we heat it up, and we heat it up over numerous layers. And then we take that powder and we put in some recycled powder, which was some fresh powder, and then we're good to go. The other thing that we'll need to do is run a bed temperature calibration. So all our machines are calibrated at factory, but for this specific material, and for any material that's kind of more sensitive to heat changes or difference in thermodynamics, what we want to do is run this bed temperature test. This is just a test that we would send you or that you download from our support site. And then essentially you will monitor that test or monitor the results, and then you will put in a specific temperature based on what that test tells us we should do. So it's a very, very seamless workflow. Typically, we'll be able to get that done within a day, so you can start up. But it is worth mentioning, when you first start, you will need to run these calibration things to get started with this specific material, Nylon 12 white. So next, guys, once we've done that process, I mean, you saw already as a beta customer, you went through it, right? When you don't run that process, again, it's not like we're saying to do this just for the sake of it. If you do not run that process, typically you're going to have a process where the powder is a bit more clumping together, which can be a bit problematic, or you're going to have things like, really rough surface finish and things like that. And so to get over that, we calibrate. But once we've done that, then we go to preform, right, guys? So maybe you can talk us through preform quickly and how many parts you can fit in there and what that process, how long does it even take you, that kind of stuff.
Yeah, so preform is the Formlabs software. It's really, really easy to use. It works perfect. You send in your file, STL files. I thought that there was an update, so you can now upload multiple 3D files.
Yeah, so you now have 3MF, you have OBJ, STL, like you said, and also STEP as well. So that's great that you can put in those formats.
Yeah, basically in preform, you want to pack in your printer as efficiently possible. It's really easy to use, and from preform you send it to your printer.
Okay, great. And then we are printing. Essentially, this is the bit where we're completely hands off, right, guys? Once we set our printer up, it's just going to print away, and we can go away and prepare the next design or the next builds. Right. What's cool about printing now is that we do have built-in cameras, so you can see what's going on during every single layer of the print. But more importantly, the printer can see what's going on and respond if it sees, things like errors during the build. Right. Then you're unpacking, guys. So how long do you normally spend for unpacking these parts in the SIFT?
I take about 10 to 15 minutes. Depends if you have a few large parts or a lot of small parts. For the small parts, we internally designed a small tumbler that fits in the sifter, so we can keep our process automatic.
Very cool. Optimizing our devices to your workflows. That's great. I love it.
Yeah, but it's really easy to use. I don't know. Yeah.
And I think that's an important point to mention. If you were not using a Media Blaster and not using the blast, you'd be spending more like half an hour, right, in the SIFT. But using Media Blaster, it means you can move on quite fast, right?
Yeah.
And so to finish up the process, we are going to blast our parts, as you mentioned, using blast for cleaning, right? And using the other blast for polishing, right? That's going to give you essentially a better surface finish on your parts. And then finally, you tumble your parts. Correct, guys?
Yeah.
And also, you've seen, for instance, things like surface finish reduction or surface roughness reduction, right, from tumbling and polishing.
Yeah, it works perfect.
Okay, great. And so that's just some things to bear in mind, guys, about the difference in workflows and particularly CW's workflow and how they're able to get those beautifully white end-use parts. So super important. Again, the more we can use blasting and polishing and tumbling, the more we'll essentially reduce our surface roughness and create beautifully smooth parts. We're just going to quickly talk very quickly about dyeing, and really just a call out to mention that we have a brand new video and also a white paper available on how to dye. Guys mentioned a couple of different phrases there, like pot dyeing before. Essentially, that is when you just heat up a pot on a stove. In this case, we're using an ultrasonic heater, which heats the dye up. The dye normally comes in a sachet. We put that into some water. The ultrasonic helps agitate that, but also heat up, because we need to heat that up so we get a homogeneous mix. The great thing about white is we can literally chuck in this white part, this shin guard you see here. We chuck it in for literally a couple minutes, pull it out, and then we wash it under a water, essentially, to get off any residue of the dye. And then we have like scratch-proof, beautifully dyed parts. The amount in which you dye, or the vividness of that color, is going to depend on how long, essentially, you leave the parts inside. All of that juicy information about tips and tricks about how long to leave things inside, what particular type of ultrasonic to use, it's all available on our white paper that you see screenshotted on the bottom corner there. And so, yeah, as I mentioned, it really is a game changer in terms of having easy to dye parts. Having a white base means that we can get really, really beautiful, vivid colors. There is other ways to do this. For instance, there is manufacturers like Dimensions that create automatic machines, and that's something to think about as you scale up and want more automation, so you can spend more time on other tasks. So guys, over to you. We're nearly near the end. So I'll leave it over to you to mention this one.
Yeah, we want to offer you guys a 20% discount on your first order, available from now till January 31. I do want to mention,
very generous
if you
offer,
guys have questions or want to contact me, these contacts, you can use them. You can contact me personally. We're happy to help you. In a webinar like this, I can tell you everything. So if you feel free to contact me with questions.
Great. And I can vouch for it. Guys is extremely knowledgeable. The team at CW are producing parts that are exceptional, as we've seen. It's really good to be able to learn from them and use Geiss & Co., even if you have a fuse, to be able to use them in order to get some parts and materials that maybe you're not necessarily going to run as a start point, I would always advise getting some prints done from CW to really assess the materials, and also those post-processing steps that maybe you don't have right now. So we are pretty much at the end of our content, and we are going to pull up another poll so you can answer some questions for us. Again, they're really going to help us tailor future presentations to your needs. Hopefully you see our dedication to our customers and prospects is doing these kind of things. We want to make sure it's useful to you. And we also want to answer some of your questions that you have in the chat. So whilst I don't think we'll get through to every question, we will try and pull out some of the top questions in the next 10 minutes. We'll give you a couple minutes to answer that poll, and we'll go through and start looking at some of the questions. Great. Just call out Joshua Driggs first off. He says the blast is great. He loves his. I couldn't agree more with you. Joshua, honestly, it's a game changer in terms of time and saving time. So you can put your time back into, again, developing your next part. I have good dye results with a pressure pot dyeing. Great. And so that's another way, exactly similar to using the ultrasonic. By the way, I didn't mention the dye that we were using in those images is the RIT Proline dye. That's the Proline one specifically is really good at creating really nice, vivid colors and not having to submerge your parts for so long. So let's answer a couple questions. All right. So we have a question here that says, how hard is it to switch from regular nylon 12 to nylon 12 white on both fuse and sift? So, so Geiss has done a very quick answer for you. It is not impossible, but it is going to take you probably a numerous throwaway builds and also at least 4 hours of cleaning. The thing that you need to bear in mind, if you are switching a fuse, it implies that you're also going to switch a sift as well, for instance. So that means that you will need to clean out 3 hoppers essentially. What's difficult with nylon 12 and to nylon 12 white is that any powder that's left underneath the dosing mechanism or the recoater, all these things that make the powder, fusible essentially by pushing the powder into the print bed, the powder can get into those areas. So essentially what happens is you'll have to run a couple builds for those things to actually come out during those test builds. So it's not impossible, but it will take at least a day, probably to clean and to run some tests at least. And then you really want to be, starting small and essentially going from there when you are switching from nylon 12 to nylon 12 white. Ideally, you would start off with a fresh printer that's never been used for nylon 12 white. By the way, all the cleaning instructions are online and in our support site. I'm really proud of our support site. So everything we mentioned today, everything from printability to design guide, if you, for instance, typed in using nylon 12 white into Google or directly into our formlabs.support.com, you would actually see a specific guide telling you about what to clean and how to go about that process. We have Joshua here that said, what type of tumbler do you use and what does that provide beyond the blast? So maybe we can go for that one, guys, a bit. Maybe, and we never actually mentioned the actual brand of tumbler, if you remember it off the top of your head.
Yeah, it's Chromas.
Chromas, and it's the specific type is a vibratory tumbler, right?
Yeah, exactly. And I do need to say we use the ceramic chips. It's especially manufactured for 3D printing. And what it does, it provides a smoother surface, basically.
Yeah. And so if you imagine like a kind of a hill, right? Like with materials like nylon 12 white, as you saw in our printability chart, when we say surface finish, we say good and not best. For instance, the surface roughness is a bit rougher here in nylon 12 white versus standard nylon 12 white. And you can imagine like little hills that create that roughness that we feel and see. When we use the polishing media, we can start to reduce that. Those polishing beads, those poly beads help with that. But when we add the tumbling on top, we essentially just add to that process. Those hills that we couldn't smooth out, because we're using a much more stiffer media, or the ceramics that Gijs mentioned, that essentially gets us to a smoother surface again. So it's kind of like, we're being subtractive essentially on top of our parts. Hopefully that answers your question, Joshua. Michael was saying, could you possibly talk a little more about workflows Gijs has developed? So maybe that's something, guys, to mention a bit about your tips and tricks from Michael here, and for the audience about like you mentioned some things there in the SIFT, and maybe even just the specific steps that you take to help you go as fast as possible and produce as many parts as possible with great results.
Yeah, a big tip is buy a Fuse Blast. It's literally the best investment you can do. The time you spend less cleaning, it reduces the price for your products, and you can evenly clean your products less and spill more material, but you win it back with the time, really. If that's a little bit,
Yeah. We have a question here, which is a useful one, I think, for people that don't know. Someone was asking, Martin was asking, which nitrogen generator do you recommend? Now, we have a couple recommended nitrogen generators that we have online. So everything that Formlabs recommends, again, we're not producing those things that we recommend, obviously. And so when you type in SLS recommended suppliers or SMS recommended suppliers, you will find a whole bunch of ones that we recommend, but that's not necessarily the one that Gijs is using. So Gijs, what nitrogen generator are you using and why?
I don't really know exactly which brand. My boss has bought one. I was involved with that. So, but you can contact me and I will give you the details.
Yeah. As I said, if you are, the cool thing is if you are particularly in Europe, then we have a different set of recommendations to whether you are in the States and things like this. So as I said, if you are on this support.formlabs.com and you look for SLS suppliers, by the way, we should mention something because I think there's some misconceptions about nitrogen in general. There's two ways to provide nitrogen. One is you buy the bottles and you literally take it from the bottle directly into the machine. However, if you're going to be printing a lot, this is going to create a lot of waste because those bottles are heavy and they are, essentially compressed nitrogen, and so they can be dangerous as well. And essentially, they're you have to use a lot of bottles for a lot of print production. That's why generators and a compressor is normally the better way to go in terms of saving cost. And that generator, essentially, all it's doing is separating the oxygen from the nitrogen and releasing that nitrogen into the printer, so we can actually have a really good printability with Nylon 12 and less oxidization of the powder, and essentially not creating a yellow surface finish. Yeah, one of the nitrogen generators we recommend in the States would be the Holtec. It's the SS7. And we also have the Flermo, which is our nitrogen generators that we'd recommend for the States. If you are in EU, we have a bunch of customers using Atlas Copco. And also, if you're in mainland Germany, we also have a company called DWT, which also produces generators. Okay, I think we are nearly there. Yeah, maybe just one last question. If we have 1 minute, I think we've got 1 minute. There's one question that says, in which application would you use Nylon 12 white versus, or what would be more beneficial than using regular Nylon 12? Honestly, it's really down to the actual part itself and down to the application. Applications where high contrast, like we said, is really important. And even when it comes to having a part that is going to be colored afterwards, or having a part that needs to be biocompatible in the medical world, this is a really great use of using white nylon versus the standard Nylon 12. They are very, very similar mechanically. So again, it's not a great deal of difference in terms of mechanical properties. It's really going to be if you have an aesthetic part that's going into a vertical where it's medical based or consumer based, where we want to get those really high contrast, beautiful parts. So guys, we wish we could stay and take more questions and talk more. Hopefully it's been useful. I really, really thank you guys and CW Development for not only being part of the beta, but also, you know, creating great products with our devices. And hopefully people can learn from you and you know, again, reach out to you specifically when you have more questions or even the need for printing white parts. So thank you so much, everybody, for joining us. It's been a great pleasure to talk to you today. Please do get in contact with either guys or directly with us at Formlabs. And we're very, very happy to hear your questions and work with you. So thanks so much. Thank you, guys.
Thank you.
Bye-bye.